Hi everybody, everyone and audience. Meet with me again in this time. This moment, I would like to present my paper review regarding computational thinking. What is computational thinking? I will introduce later. And this paper I took from Computer in Behavior. This comes from Elsevier, and this is the famous journal. And the title of my paper is Can Computational Thinking be Improved by Using Methodology Based on Metaphors, Scratch, and to Teach Computer Programming in the Children's. The author from this paper is Diana Perez Marins and from Madrid. And this paper published or accepted in 2018. And before I will introduce about this paper, so I will introduce myself first. My name is Andik, and this review I use for assignment for ubiquitous course in my study. And from before I introduce what is the content of this journal, so I will introduce about this journal first. So this journal I took from Web of Science, and in here we can see this qualification of this journal is Q1s, and they have impact factor is 4.3. I think the higher impacts, and this is categorized from SGI and SGI journals, from the Computer in Behavior journals. And this paper already citation this once, but I think that is a new paper. And the first time I will introduce about the introductions, and the introduction about the city. City is the skill of the problem solving and design system and understanding human behavior based on the computer science concepts. This announced by Wings in 2006, and after that Wing announced this one. The computational thinking, or I call it CT, is become interest field to be conduct a research about these ones. And Wings in 2016 they established some books. The name is the title is Computational Thinking 10 years later. And this is the Wings. This is she is a woman, famous. They work in Microsoft company in US, and this is the famous woman. They have some the founder of the computational thinking. And from the book from the Wings in 2016, the computational thinking letter, they have some unclear or most effective in the children's, how to teach in the children. So this is introduction why this paper they conduct to solve or maybe to answer this challenge. And last year, several authors claimed that CT be acquired and developed by teaching program to children. For example, in 2013 from Kazakov, and 2014 for McCartney, and 2015 McCartney and Starhacker, and 2016 is Heinz Manila and Papadakis. From this each year, every years they have some increment or maybe increase the number of study about the computational thinking. And CT can be acquired by other means, such as the first is educational robotics, storytelling, unplugged activity, and scratch GR, and ethic lessons, and so on. And maybe in the develop now in current year, maybe they have many how to teach or how to learn about the city to the childrens. Common approach to teach computer science to the children using the scratch. And what is the scratch? This is which ones of the program they developed by MIT Media Labs, and this is developed use consider about the children ability. So this program is adjust by children's what they have, what they do, and what they can from the children ability, and developed by lifelong learning's kindergarten research group in the MIT to design interactive media by snapping together programming instruction blocks. This software we can get free from some platform in the website. You can search in the Google. They use the keyword scratch, and you can find out its download is very free. Other approach, another from scratch, some research they have softwares such as Makey, Lego, Wido, or Mindstorm, and robots making games. And the next from this paper, I got the challenge from the city computational thinkings teach to the children. The first is they are difficult in teaching children even basic concepts such as program constructions, loops, structure control, and algorithm. From fourth part of the basic concept of the computational thinking, the constructions, loop, and structure control algorithm is this term come from the computer, how the computer works principles. And these difficulties arise because the poor of the teacher trainings or lack of the proper teaching methodology. And the opportunity from this research is we propose and validate the use of metaphor to introduce the children to basic concept of programming according to the methodology MechaProc. What is MechaProc? MechaProc is one of software in this research they use for teach to children about the programming. And I put in here some sentence metaphors. Maybe all of you maybe is strangers upon the metaphor, so I put in Indonesia the call is kiasan, and in Chinese this ones. And the background from this research is the about city in long time ago in 1915. We know about the algorithmic thinking. This algorithmic thinking is a way to use algorithm to produce appropriate output to given the input. And 2006 Wings relaunch is involved solving problem, design system, and understand human behavior by drawing on the concept fundamental to computer science. And 2013 City include the composition pattern, decomposition, pattern generations, locations, abstraction, and algorithms. And in 2014, City is term of programming, more specifically using Scratch based on 3D city classification into concept practice and computational perspective. Interest teaching programming several countries we can see in the next table. From several countries such as Australia, England, Estonia, Finland, New Zealand, Norway, Sweden, South Korea, Finland, US, and Macedonia, and they have some compulsory as a course in they have many level as the subject to learn in the children's. For example, from Australia, they have some content called is digital technology, and this is the tab is compulsory, and then I will took in US. They have called its name is computer science, and this is the own subjects, and this is the secondary is is optional. But I think some country they have concern about the computer thinking, how to solve the problem. So they involve teach the computer science, computer thinking, and computer maybe another science about the computer. From the research, I got the participant is 132 from primary education students. This is in Spanish, and 56.1% is male and 43.9% is females. And age they around is 9 until 12 old, and 50% of our participant is attend or in private schools, and the rest of attend is 32 different public school. And in the figure I put some proportion using the pie charts, and they have 60 grids is almost similar with 50 grids, and maybe more less than is 4 grids. And longitudinal pretest post-test from this is used from the method in this research, quasi-experiment design, and not provide a control group, and we could not randomly assign students, and room were only available from 10 o'clock to 2 p.m. and we divide student in the 5 grades attend from 10 to midday, and 6 grade from midday to 2 p.m. Maybe it's sessions they have just have time is 2 hour. And the next is about the flow diagram of the experiments. This is from experiment. So the first time in the study they have some pre-test, and after that student be teach about the concept about the city, and in here student learn city using the Scratch, and they have some software called is microproc. And after student finish learn about the Scratch, they have some test. The call in here is CTL test. Maybe I will introduce later about the CTL. And in the end of this experiment, they involve some computer thinking applications. And in the last is they using the pretest to evaluate from the experiments. The metaphor used in this microprog, the first is program sequence. Program sequence, variable input and output instruction. For example, in here, in the figure, we can see the metaphor is we can teach in the students if they have some another things, they have something in the kitchen, such as they have pantry, they have some refrigerator, or they have some another smart tool in the kitchen. So in here, student can teach about after they learn about this one, they say hello, about say hello 2 seconds, and say I like to eat, and ask do you like it. This is learned by using the scratch. And then the next is conditional and instructions. Conditional and instruction, this is use the block 2 intelligent fridge conditional, or maybe refrigerator, and student using scratch as well to teach how to program this intelligent refrigerator. So this call is conditionals. And the last is about the loops. In here, student learn about loops. What is meaning? In here, use the metaphor. In here, loops as refers to about the hand mixers, and as well in here student learn about how to using the loops in the programming. And 3 components from the microprog and metaphor, in this research they can hope a student learn about the component of the city in the daily life. So in the next slide is about talking about the computational computing applications. This is some software the student can download from some another Play Store or maybe some web. This is from in 2018. Computing is a drag and drop visual interface from Android tablet or smartphone. And in the computational thing, we can teach students learn about the component of the computational thinking. And for example, in here they have some facility. For example, is about the menu in here. In computing, they have some like a rack of the books, and then they have some loops, and we can learn about the algorithms and patterns. For example, in here pattern student can be learned for in the right side. In here in the right side they have some the children face, and from this children face student can be recognized what kind in the face they have, and we can match with the left side. In here, for example, in the hair, where is the hair is similar, so in the hair in here is similar. And then in the eyeglass, where is the eyeglass is similar, so the eyeglass in here is similar. And about maybe in the another component in the face, so students can learn how many the pattern they can learn use this application things. And then conditional and steps and instruction, and the last is automated, or I think it's called is automations. The next slide, the test they have some term about they call it ROMT, a validated test for children to measure the computational thinkings. And then CONT, a concept test created ad hoc for the experiments, and PCNT, a new test to measure the CT based on the field of the literature. And how to measure in the research, use the variable where the score achieved by the student in the CONS, ROMS, and PCNT tests. Specifically, the following: CONS as a student's knowledge test, or maybe the CONS T scores. ROMS, student validated CT computational thinking, come from the ROMT scores. And PCNT is student new CTT test score, or I call it PCNT. And the data analysis use non-parametric tests were used because when the data gathered was analyzed, and we saw they had not come from the abnormal distributions, and we did not have enough data to assume normality. The findings in here drawn by the figures in the figure 7. They have some box plots from the variable PCNs, cons, ROM, and from pre and post test. And we can see pre, the focus is in the, for example, I took some variable PCNs in here. This is the pre and this is PCN for the post. So I think the post is more higher from the pre. So it means the learn or the student activity to learn about the computational thinking or another activity are there, they have more effective. And then for example, another is about the pre-con and post-con. They have some another increase, and another ROM there is as well increase. And from the median means and standard deviation from pre-approach test, in here in this research they provide some table 6. In here is PCN, SCON, and ROM, and in this pre and post we can see they have some increment in the result. They from 8 to 9, and the means from 8.3 and to be 8.9. And another variable in here 2 to 5, and another in here 4.2 and to be 4.7. What this means, I think, is the effective from this learning about the city in here, and another variable they have the effectively is good. And in this paper they also some provide some table result from the experiment, and we can maybe the audience can read more detail from the authentic on the paper. And I will directly to discussions. So from this paper, a statistic significant in increase the children post-test result put in the knowledge according to the cons knowledge test and CT value for all the grades according to PCNT and ROM CT test. This suggests that even in the short period of the time is possible to teach the children basic computer programming concepts such as memory, programming, conditionals, or loops, and improve their CT ability with the children as young as 9. And in the light of our results and from our experiment with the children as 9, to 12, learning how to program engage in the help this focus on the problem. In general, it is well known that the children love the computer and do not think that can difficult or the boring to use in this. And age of students begin to find this complex idea difficult to understand. In contrast to younger children, they have the problem. It has also become evident that teachers need guidance in their approach to this task. According to this study, the students are able to learn programming concepts if they are taught with methodologies such as microPOC, with Scratch, and those that use the metaphor. Given the low correlation found between PCNT and true AMT, more study should be carried out focused on how to assess the city for young students, particularly those aged under 9. And the conclusion from this paper, the first is the results suggest that using metaphors, Scratch is useful for the teaching computer programming concept to primary education students and for improving student city, providing a positive answer to research questions. And finally, 6th and 4th grade students' knowledge of programming improved, but not significant improvement was found in RUIMT or the PCNT scores. This may indicate that these students need more time to improve the city, or that the microPOC metaphor methodology is more applicable to the student age in 10 until 11 age. And thank you. This is my presentations about paper review about the computational thinking, and see you in my video, another video, and don't forget give me like and thumb up. Bye bye.